Welcome back, learners. Now jumping on to our second concept, whereby we're going to be looking at second diagrams that are connected in parallel. So in a parallel circuit, when we add resistors in parallel to each other, the total resistance of the circuit is going to decrease. And because of that, the current strength is going to increase. So as I've said, to re-emphasize the relationship between the resistance and the current is that when one of them, in this case, when the resistance decreases, the current is going to increase. Why does this happen? This happens because when we are adding resistors in parallel, we're actually providing more alternative pathways for the current. So the more resistors we add in parallel, there's more alternative pathways we are providing for the current. And because of that, it is easier for current to move through the circuit than if all the current had to move through one resistor. So the more alternative pathways we are given for the current, it becomes easier for them to move through the entire circuit because there's more than one way for them that they can choose to go. So when we're adding resistors in parallel to each other, we are re-emphasizing again that the total resistance is going to decrease and the current is going to increase. Now, what happens to the current? The current in parallel will divide when it enters the separate branches. So because there's more than one pathway, if we have now, we're going to draw it now. Now let's just continue. The total current is the sum of the current in the branches, and then also the potential difference across the branches of the battery is the same as the potential difference across the battery. So what we are saying with this is, when you have your circuit with two resistors that are connected in parallel, the point here says that the current in parallel will divide when it enters a separate branch. So your current, there's something wrong here, so negative. As your current is moving from negative to positive, when it gets to this point, it has to divide. So that's what you mean it will divide. It has to divide. Some of the current will pass through, if you label this as resistor number 1 and resistor number 2, some of the current will have to pass through resistor number 1 and the other will pass through resistor number 2. However, when these two currents now have passed through the two respective resistors, when they meet again at this point, they're going to add up to the sum of the total current. That's now the next bullet to say that the total current is the sum of the current in the branches. So the current here plus the current on this branch is going to be equal to the total current of the entire circuit. Now the third bullet says this: the potential difference across the branches of the circuit is the same as the potential difference across the battery. So if we measure the potential difference across this particular resistor here, if we connect a voltmeter across this resistor, the voltmeter will register potential difference, and it is going to be the same as if we were going to measure the same potential difference on or across this particular resistor here. So the potential difference at resistor number 1 is going to be the same as that on resistor number 2, and also going to be the same as that across the entire battery. So that's what the third bullet is saying. Furthermore, parallel circuits are useful in households. How are they useful? Because if one pathway stops working, then the other pathways can still work. You do know that if you have a 3-room house or a 2-room house, if one of the light bulbs does not work, it does not mean that the other light bulb on a different room will stop working, because there's more than one pathway for the current to follow. So if the current on the first light bulb, or if the resistor on the first light bulb does not work, that means the current will choose a different pathway which is now going to be going to the second light bulb. Hence now the reason why the two light bulbs can still work independently, or they can work independently. So we're saying this. So if in your bathroom, light bulb breaks, if one of the light bulbs at your house breaks, in this case a bathroom, the rest of the lights or the appliances in the house can still be used. If you have a 4-room house, a 5-room house, and one of the light bulbs in one of those rooms breaks, the other ones can still be used. However, in a series circuit, when the first light bulb breaks, it means all the other ones following that light bulb will not be able to be used. So that's the reason why now we are using, in our homes, we are using the parallel circuit, because we can use all the different pathways independently from each other. So if your house uses a series circuit, then all the light bulbs and all the appliances in the house would stop working if one item is broke. So if one item broke, then all the other items will stop working. Because remember, in series, all the components are connected one after the other. So for current to move on to the second component, it needs to first pass through the first component. So if the first component is broken, that means current will not be able to pass through that component. Then that means all the components following that will not be able to receive any current, and therefore they would all stop working. You can also turn on lights in different rooms at different times without having to turn all the lights in the whole house at once. So if your house was connected in series, when you switch on one light bulb, that means you have to switch on all the light bulbs. But if you switch off one, then all of them are going to be switched off. So that's also another reason why we are using a parallel connection in our houses or in our homes, because of that particular reason, that we can use each room independently of each other. Because if one pathway for the current is broken, that means the current can decide to use a different pathway, because there is also going to be another pathway that is going to be allowing the current to move from one point to the other. Now, we need to recap a bit here. We are saying this, in a parallel circuit, the more we are adding resistors, we are actually decreasing the resistance in parallel. If you keep on adding a resistor in parallel, the total resistance of the circuit is going to be decreasing. Now, because the resistance of the circuit is decreasing, then the current strength of that very same circuit is going to be increasing, because the relationship between the current and the resistance is inversely proportional. When one increases, the other one is going to be decreasing. Now, with all of that said, I hope you had as much fun learning about this circuit and all the other information that we have shared. And until I see you next time, goodbye.